Alright, so today we're exploring the pentose phosphate pathway, or PPP, a critical yet often overlooked part of cellular metabolism. The PPP is deeply intertwined with glycolysis, allowing cells to adapt dynamically to changing needs, whether they're focused on energy production, biosynthesis, or antioxidant defense. At the heart of the PPP and glycolysis connection are two key intermediates, fructose 6-phosphate and glyceraldehyde 3-phosphate. These molecules can flow between the two pathways, ensuring that the cell can shift its metabolic focus based on current demands. When cells need NADPH or ribose 5-phosphate, for instance during periods of rapid cell growth or under oxidative stress, glucose 6-phosphate is rerouted from glycolysis into the oxidative phase of the PPP. Here, NADPH is generated, acting as a critical reducing agent for anabolic reactions and defense against reactive oxygen species, or ROS. Fun fact, NADPH is crucial for protecting cells from oxidative stress, especially in cells like red blood cells, which encounter high levels of oxygen. In addition to NADPH, the non-oxidative phase of the PPP produces ribose 5-phosphate, an essential precursor for nucleotides and nucleic acids. This makes the PPP vital not only for energy balance, but also for the synthesis of DNA and RNA. Fast-dividing cells, like those in cancer, rely heavily on the PPP to support rapid DNA synthesis. This metabolic flow is not one-way traffic. When cells have an excess of sugar phosphates, such as ribose 5-phosphate or acetoheptulose 7-phosphate from the PPP, they can be converted back into fructose 6-phosphate and glyceraldehyde 3-phosphate. Once redirected, these intermediates can re-enter glycolysis, helping the cell focus on ATP production and energy generation when needed. This flexibility between glycolysis and the PPP allows the cell to switch its focus based on immediate needs. For example, during oxidative stress or high anabolic activity, such as fatty acid synthesis in adipocytes, the cell prioritizes the PPP to generate NADPH. Conversely, during intense activity like muscle contraction, glycolysis takes precedence to maximize ATP production. Fun fact, muscles prioritize glycolysis during activity because it's the fastest way to generate ATP for energy. Ultimately, the cell's ability to shift glucose 6-phosphate between glycolysis and the PPP is a prime example of how interconnected pathways help maintain metabolic homeostasis. This dynamic balance enables the cell to respond efficiently to different conditions, optimizing for energy, reducing power, and building blocks needed for growth and repair. So to recap, the pentose phosphate pathway links directly with glycolysis, allowing cells to adapt their metabolic focus as needed. From generating NADPH and ribose 5-phosphate to re-entering glycolysis for ATP production, this flexibility ensures that the cell meets its diverse needs for energy, reducing power, and molecular building blocks. If you enjoyed learning about the PPP and want more in-depth resources, be sure to check out King of the Curve for additional study tools to boost your understanding of metabolism and more. Thanks for watching, and see you next time.